The optimum formalin to be specimen volume ratio should be at least 120. This will allow must be tissue that because a tablet fixed within 48 hours. Fixation. Most commonly used reagent for the fixation 10% neutral buffered formalin. Formalin container should be capped that leak proof and labeled correctly. The tissue by itself should be of the size to 2 mm, 2-3 micrometer in thickness. These bites are then placed in metal caskets or casters with are then placed in the fixative. Tiny biopsy or small specimen can be wrapped in a filter paper and then put in cast fixed to help in visualize of a small fragment of tissue during emitting a few drops of 1% oxygen added. Type of fixative physical method heating, microwaving, freeze drying, chemical methods. Coagulants fixative, precipitate and coagulate protein, alcohol and acetone, picric acid and nitrichloroacetic acid. Cross linking fixatives. Formaldehyde and glutaraldehyde, other aldehyde, chloride hydride, and glycol. Mental source by quick and zinc chloride, assuming textiles component fixative. Physical fixation. Microwave irradiation fixes the tissue more than effectively. Large specimens which are soft cut and can be radiation of the brief period. Then the tissue blocks are cut. The procedures of dehydration impregnation is accelerated. Tissue antigen are well be preserved following microwave irradiation. Microwave processing can be applied in electron microscopy. Other fixative glutaraldehyde and oxalate tetroxide. Via fixative stock solution mercury chloride, sodium acetate, distilled water. At 2 ml of formaldehyde, 2 ml of stock solution. Jangle fluid, boinal fluid. Specimen transferred to the cassettes. After fixation, specimens are trimmed using a scalpel and enabled in the appropriately labeled tissue caskets. The specimen should not be big that they will be the cassette. They are the trimmed as not to attach the heads. Additionally, they must not be too thin, otherwise they risk being warped when the cassette lid is closed. The filled tissue cassettes are then stored as a formal until processing begins. Washing. Following fixation, the tissue should be washed for 15 to 30 minutes. The fixed tissue are washed in running tap water. Remove fixative from them. Tissue processing. Processing tissue into thin microscope sections is usually done using a paraffin blocks as follow dehydration, emulsion, immersion, specimen in increased concentration of alcohol to remove the water and formalin from the tissue. Clearing organic solvents, for example, xylene is used to remove the alcohol and allow the filtration in the paraffin wax. Embedding specimens are infiltrated with the embedding agent, usually paraffin wax. The tissue becomes surrounded by the large blocks of molten paraffin wax, creating that the now referred to as the blocks, providing a sport dehydration. Wet fixed tissue in an aqueous solution cannot be directly infiltrated with the paraffin. First, the water from the tissue must be removed by the dehydration. Dehydration must be done gradually, example within a series of alcohol, 70% to 95% to 100% to prevent turbulence of the interface between water and pure ethanol, causing damage or resistance to cellular components. The number of steps are the guardian differential which determines the degree of fixation, the resistance of the tissue, the degree of the cellular detail to be preserved. Sometimes the first step is a mixture of the formalin and alcohol. Dehydration agents are strong hypophilic possessive strong polar groups that interact with the water of hydrogen binding must form a dehydrate used in regular. Other dehydratants can be used but have major disadvantage. Acetone is a very fast but is a fire hazard. So is a safe only from a small hand processed sets of tissue. Directs only can be used without clearing but the toxic fumes ethone acetate isopropyl alcohol clearing. The next step is called clearing and consists of removal from the dehydrate with the substances that will be miscible within embedding medium. Clearing agents therefore act as an intermittent filtration of dehydration embedding. They provide translucent appearance to the tissue. Choice of the clearing agent depends upon the flowing rapid penetration of tissue, speedy removal for dehydration issue, ease of removal by the melton current, minimal tissue damage, safety factors, low availability, low toxicity, cost and convenience. Clearing. The common clearing agent is the xylene. Other clearing agents include toluene, chloroform, methyl salicylate. Toluene works well and it's more tolerant from small amount of water left in the tissue, but it's 3 times more expensive than saline. Chloroform is used but is the health hazard and slow Methyl sulfur salaries are really useful because it is expensive but it smells nice. It is a wintergreen. Excessive exposure to clearing reagent may cause excessive hardness or shrinkage. Impregnation and paraffin. In the process of infiltration allowing to paraffin penetrating between the cells of the tissue. This process is paraffin infiltration is a necessary step to harden the tissue before their embedding. Hence, their tissue are put for 6 to 24 hours in a hot soft paraffin 50% 50 degrees Celsius. Then it is a hot hard paraffin to at 55 degrees Celsius in the oven. Infiltration must be carried out the only few degrees above the melting point of paraffin. Paraffin wax the most popular infiltration and embedding medium. It is a mixture of a long chain hydrocarbons produce a mineral oils. It has permits the tissue in liquid form as solidify rapidly when cooled. The paraffin wax increase the optical differentiation hardness. The tissue helps easy sectioning of the tissue. It is compatible to the most routine spatial strains as well as immunohistochemistry protocols. Alternative embedding media resin gelatin and collagen embedding blocking. Finally, the processed tissue is to be correctly orientated within close the embedding or supports medium that provide external support during microtomy. The embedding agent is almost always paraffin. Paraffin is derived from protein. It is a group of variable length long chain hydrocarbons of the main methane series. The most paraffin suitable as embedding media melt between 52 degrees and 58 degrees Celsius. Since the most paraffin have a melting point between 5 to 58 degrees Celsius, it must be inflated the cells while till it's cold. Embedding blocking. Impregnated tissue are placed on the mold of their labels and their fresh melted wax covered and it is allowed to settle and solidify. Once the blocks has cooled sufficiently to form a surface, skin should be immersed in cold water to cool dry rapidly. After the blocks has completely cooled, it is cut to noodles blocks and each are removed. Label are the made of adhere to a surface of the blocks embedding center. Embedding process, microtomy, sectioning and cutting. Microtomy is the means by which tissue is sectioned that attach the surface of the microscopic examination. The instrument by this is done is called as a microtome. Types of microtome: solid sliding, rotatory, rocking, freezing, base ledge, ultramicromicrometry, microtome knife, disposable bladed glass diamond knife, paraffin section setting, equipment required flotation, water bar, sliding, drying over the hot plate, forceps, brush, anti-aging, needles, clean, slide rack, diamond pencil, section adhesives, albumin, gelatin, starch, polylization, free amino, probable silence, charge of the plus slides. Specimens are cut into sections that can be placed on one slide. Trimming wax is removed from the surface of the blocks to expose the tissue. A microtome is used to slice extremely the tissue section of the blocks in the form of ribbons. Most tissue are cut around 5 micron. Floating tissue ribbons are carefully transferred to